All right, well, welcome back to the channel. I'm Paulo Shakarian, and this is the Neuro Symbolic Channel. And with me, we have Luciano Serafini and Sami Badruddin. These are two of the co-authors of the Logic Tensor Network paper that we have covered in a couple of other videos. And would just like to start out by having them introduce themselves and maybe tell a little bit about their background. Luciano?
So nice, Paolo, for inviting us for this interview. So my name is Luciano Serafini, and I just, Paolo pronounced my name correctly. That's very good. So my background, so I'm already 30 or more than 30-year researcher in artificial intelligence. I started more on the symbolic artificial intelligence, knowledge representation, theory of context, and then I use this all this knowledge about logic-based knowledge representation for semantic web and so integration of different heterogeneous knowledge. And then around by the end of 2010, I start thinking that it would be very, very interesting to integrate machine learning into symbolic knowledge. So I start very few works, but then in 5 years, we come up with this idea of logic tensor networks, which basically integrates the logics and neural networks. So you can integrate the logical reasoning and machine learning. And then this was actually a very successful story. And I'm now continuing this topic of research in my career.
Oh, thank you, Luciano. And maybe Sami?
Sure. Thank you also from my side for organizing the interview. I'm Sami Badruddin. I'm an AI engineer at Sony AI. So my career is much shorter than Luciano's. I have a 3-year experience in AI. I graduated with a master's from the Free Brussels University in Belgium. I studied civil and computer engineering, and then as part of an internship at Sony, where I'm now working, I was working with Michael Spranger, who introduced me to Neuro Symbolic AI, and more specifically LTN. I absolutely loved it, and I decided to join the LTN initiative after I graduated and do more research, collaborating with Luciano and also Arthur Garces. Yeah, that's it.
Oh, thank you for that. So, so this is the Neuro Symbolic Channel. And, what I think has been interesting that I've noticed, as I've started to explore this area and talk with different people over the past year or so, is that a lot of folks involved have a little bit different perspective based on their background. And so I'm wondering, maybe in your view, how do you define neurosymbolic? Maybe start with Luciano.
Okay, so as the word states, neurosymbolic is, for me, it's a very technical, has a very technical meaning. So it's about integrating neural networks, whatever they are, okay, every type of neural networks. So, which is a computation based on based on the composition of, say, relatively simple functions, but you have many of them, and you have many parameters. In which you can perform a very nice task like optimization, gradient descent, and all these kinds of things. With the symbolics, in which symbolic knowledge that are represented with symbols, and the problem is that symbols they need to have a grounding to the reality, and neural networks, it is what they provide, is what provides grounding, meaning of symbols, because symbolic reasoning instead are only concerns of symbol manipulation, okay? So we want to have symbol manipulation together with the meaning of the symbols attached to these symbols, okay, that are provided by neural networks. So I'm interested in combining what you can get from symbolic manipulation and what you can get from symbol grounding that are provided by neural networks.
So in your view, would something like, AlphaGo, would you consider that neurosymbolic, or would you consider that something else?
I see AlphaGo very, very symbolic. It's something that you are simply manipulating a large set of symbols, a large set of states. You don't have really a connection with reality, with the perception, with the meaning of that symbols. It's, the reality there, it's still a game that is a discrete and very abstract concept. So I wouldn't consider AlphaGo that to be neurosymbolic.
Sammy, what's your take?
I think I have a little bit narrower perspective. For me, the symbolic part stands not for any symbols, but specifically symbols are described with usually relational knowledge or logical knowledge, and where we use this specifically in the method as well. And I feel like, for example, because AlphaGo is doing the abstraction of the symbol and doesn't really try to relate them using say binary predicates or anything, for me, I wouldn't consider it neurosymbolic. But I feel like this is maybe a discussion for theoreticians and or philosophers, and yeah, my opinion is not that strong.
No, I can understand that. Kind of along those lines, you guys have been doing some great work, and it's been, very research centric. And you said you're now with Sony, Sammy, right? So what role do you see academia versus industry playing in advancing research, particularly in the field of AI?
Yeah, that's a very good question. What I would want to see academia keep doing is to keep exploring, let's say, AI models are impressive, but also accessible to researchers with any resource. Whereas I feel like the industry, let's say, for example, the biggest feats recently coming from the industrial research, not everyone has the resource to accomplish that, GPT or anything. And at Sony, I feel like, depending on the team, we're somewhere between the two and trying to connect the two. Yeah, that's how I would describe my understanding of the difference between industry and academy so far.
Okay, should I also answer the
question?
Yeah. Okay. Yeah, I am perfectly in line with what Sami says. I think despite his short experience, he provided a very important answer. Academia has the responsibility to investigate, to think to think 10 or 20 years ahead what could be interesting, and to do this, it should be motivated more from the speculative point of view, to try to investigate a new solution, completely new solution. But then these should be solutions for real problems, and real problems are always provided by the industries. I think that we cannot go too much we should, I mean, research should be, try to take the challenges of industry and go a step ahead from these challenges, but it should take these challenges. And then industries, I think it should be ready to understand what is going on in the research, and have people like, in this case, Sami, that are enthusiastic about the result of the research and are able to even to take the research and see it in the context of the research objective of the industry. Okay, and I say Sami, but I also can mention Michael Spranger, who was a collaborator with us, who works in Sony, and I think he is playing the right role in this. So tight collaboration between the two should be important.
Okay. I mean, kind of along those lines, in recent months, we've had things like ChatGPT, and then Google had the Bard announcement, and these advances they made do not have an associated publication with them describing their methodology. Contrast that with, of course, academia. I just got back from AAAI last week, and we want to publish everything. Do you view this, these rapid advances by industrial groups as hindering open research, or is it exposing new things that are giving academics something more to look at? Because this is, for me, this has been very different from back when I got my PhD. This didn't seem to happen so much.
Okay, I start. That's a very difficult question to answer. I also was in AAAI, just came back yesterday. And there were a lot of reference to this GPT and these big language models. And I think that research has to take into account this. This achievement, independently from how this achievement has been reached. I mean, there is a lot of discussion if this is a piece of knowledge or as a piece of engineering or something in the middle. It's very difficult to say. But it's undoubtable that some of the, at least for my perspective, some of the issues that we discussed quite a lot in the past about common sense knowledge and things like this, ChatGPT has an impact on this. And it, at least for my research perspective, and for the neurosymbolic research perspective, as far as I understand, ChatGPT is deeply based on a neural approach. Okay, they call transformers. But in language, we have structure, we have rules, we have many things like this, and try to see how these two types of informations can be integrated would be, it's a challenge. It's something that challenged me.
No, I mean, I totally agree with you there. I think that, and I think at your comment about, is it engineering, is it research, is it something in the middle? I think that's very interesting. And I also think that, part of me wonders if OpenAI, one of the reasons they released that was to effectively do just a giant experiment on users and see what people would come up with. I don't know, maybe Sami, do you have a perspective on this, especially coming from industry?
Yeah, no, completely agree with everything from coming from Luciano about the fact that it's not open source and so on. I think there's nothing we can do. It's the industry that they need to make perfect at some point. And about the discussion about research and engineering, I also feel like we're moving in a direction where the two are go always together from now on. And I feel like while the academia cannot take in all the resource needed for like those huge engineering projects, what they could learn from the industry is sort of like project management practices. So GPT, AlphaGo, and so on, those are huge team efforts, and those come with a very strong engineering culture in how to manage that. And I'm curious to see if in the next decade, the academia will start to sort of grow this culture and have people starting to manage projects in such a big scale, maybe less resource, but still big scale like this. Yeah.
No, I think that's a really fair point. I have seen, so I took a couple years off to work at a startup, and coming back and creating a new lab, I've noticed that a lot of the candidates are for PhD are coming with, a lot of industry experience, a lot of engineering experience. And it's really changed the culture of my lab from the first time I started a lab, back in 2014. And that's been a big difference. I think it's been good in many ways, honestly. But speaking of students, to wrap up part one of this interview, what advice do you have for students going into the field of AI?
I let Sami to answer first. He's have a first-hand experience.
I was thinking that too.
Yeah, this one talks to me because I've been there very recently. I think neurosymbolic, if we're talking about neurosymbolic AI, it's an extremely large field, and it can be a bit overwhelming where to start with. There's so much theory, so many frameworks, and at least I was a bit overwhelmed with where to start with. So one advice I would give for anyone starting is don't spend too much time on literature review. At some point, once you have a problem,
I might edit that out for some of my students.
Yeah, because it's never ending, this process of literature review. So I think at some point, if you have a problem, just pick one of the framework, try to quickly spin some experiments. If there is a limitation, then you can make a better informed choice for your next framework, or even better, you can bring improvements to the framework, which is what I did with LTN. And I think that's worked well for me. And the second advice I would give is following what we were saying, try to grow some engineering sense, software engineering sense, not only about practical things like GitHub and so on, but also try to have a quick look at project management, things like Agile or any other project methodologies for working in teams. And I think it's going to help a lot. It has helped me a lot in how to start my career.
No, thank you for that.
Okay. So my perspective is kind of complementary of what Sami says. I think it's okay not to just spend too much time to have deeply understand all the possible frameworks of neurosymbolic integration. Just pick one and try to do this. That's a good suggestion for me. What I would add on this is try to understand the philosophy and the basic ideas that are behind that particular approach. This is the only way that you have in order to maybe improve the approach and extend it or change it and overcome the limitations of the approach. I think it's important to have not only to being able to use the tool, but it's important to understand the tool, to understand what really is going on inside the mechanism of the formal, or the mechanism of the approach that you take. Okay. Also from the theoretical point of view, not only from the experimental point of view. I also think that it's an important part. Yes.
No, thank you for that. I mean, I think that's kind of interesting what you touched on, understanding kind of the theoretical underpinnings behind a framework, and and then how that causes that framework to behave. And one thing I've really noticed, in looking at different frameworks, from LTN to LNN to some of the more deductive focused work, is each has been designed with a set of assumptions, and they've endowed different capabilities in those different approaches. Well, that will be it for part one of this interview. Thank you both. And if you're watching the channel, thanks for tuning in, and please subscribe to catch up with us for part two. Thanks. All right, welcome back to the Neuro Symbolic Channel. This is part two of my interview with Luciano and Sammy, two of the authors of Logic Tensor Networks. In this part of the interview, we're going to actually talk a little bit about their work. And if you want to learn more about all the technical details of Logic Tensor Networks, we do have a series of videos as well on the channel. So let's start out, and whichever of you wants to answer this first, just briefly describe logical tensor networks at kind of a high level.
Should I start, or?
Go ahead.
Yeah. So in very few words, logic tensor network is just a neural network where you encode some logical formula into the loss function, and you try to train the network to satisfy as much as possible that logical formula. And the point is that the output of the neural networks are used to establish the truth value of the predicates that compose this formula. And then you can compute the truth value of the formula by simply applying the semantics of the connectives and quantifiers. And this gives you the final result on how much your formula is satisfied. And the training is just try to learn the basic neural network so that such a truth value is maximally satisfied.
No, I think that was really a nice, concise description. Along those lines, I think one thing, actually two characteristics I found interesting with it is, one, your decision to use fuzzy logic as a way to propagate the gradient back through the network. And two was your decision to, your layers of parameterization lied below the actual definition of the logical symbols, and you use the term grounding that associates the logical constants with the underlying neural structure that builds that up. In this, both of these, I think, are different than other design approaches. So like neural ASP, they do not propagate the gradient through the logic to the network, and logical neural networks, they parameterize the operators instead of the underlying logical constructs. So what drove those decisions?
It's very difficult to say, but I think it's the how can I say, the fact that I was aware for a long time during my career of knowledge representation that I was manipulating symbols without any meaning associated, real meaning associated to these symbols. For example, sometimes I was reading paper, something like that contains predicates like father X and Y implies parents X and Y. This paper assumes that this implication was magically true, okay? Just because you call it father and parent. But the point is that without symbol grounding, without grounding these symbols to the reality, to the perception that concerns the relationship between X and Y, you will never get these out. I mean, you can call these two parents and father with two completely different names, like Pippo and Pluto, whatever, just two random words, and the theory will remain the same. But I was fascinated by giving meanings to that symbols, and that's why I also call them groundings.
Yeah, I thought that was an interesting choice of words. I mean, my background is logic programming, and when I first read that you were calling that grounding, I actually got a little upset because I'm just used to the idea of moving from non-ground atoms to ground atoms, and that process being called grounding.
Yeah.
Now I know in things I've read since then why you've made that choice. But maybe if you could describe, why you use the word grounding in this way.
Because I was fascinated by this idea of symbol grounding. So you ground, or I could have used also anchoring, but grounding, I like it more. There is a paper, I think in 2001, or I can't remember the author, that was introducing this idea of symbol grounding, which is the problem that an autonomous agent has to create a correspondence between a symbol, an internal symbol that it uses to represent knowledge, like in a logic program, and the perception that it has about that object. Okay, and this connection is called grounding, and that's why I call it grounding. Okay. Also, the name was, I think, lately used by the people who did image and language alignment. And one is called the textual grounding. It's a task in vision that aligns a text of a caption, the elements of a caption, to the bounding boxes of the objects in an image.
Oh,
so this is also called grounding, okay? And I was aware of the confusion that I will have created by the people, by the logicians that use grounding in the terms of instantiating one variable into a constant. But the constant itself is just a symbol, and it needs to be grounded to the reality itself. John is just a symbol. You have to ground it to your capability of recognizing John, of saying, okay, this is John, and this one is not John. Otherwise, that remains a symbol.
No, and I think this was something I found really interesting. Also, for our viewers, I'll put a link to one of our videos about symbol grounding, and we've looked into this in other frameworks as well, like SatNet. So, Sammy, in part one of our interview, you mentioned that when you got exposed to LTN, you had some ideas of how to extend it. What were those ideas? What extensions did you contribute to this framework?
So when I started working with LTN, I started trying to, as I was saying, spin a few experiments. And to do this, I tried a bunch of the examples that were at the time implemented in the LTN repository. And the limitation I found is just that some of the examples didn't learn, even though the logic made a lot of sense. The symbol grounding made sense. The neural network couldn't learn. And it took me a while, but I figured out kind of at the same time as some people from the Vrij University from Amsterdam.
Neil van Krieken.
Yeah, right. They published a very, very interesting work where they analyzed the gradients, how the derivatives work for different fuzzy operators. And with this insight, I started to look in LTN in a very different way. I sort of like forgot about the semantical part and so on, and just looked at it as a loss function. And this is where I started to contribute to LTN, because I noticed why some stuff were not working. Why some operators work better than the others, and what I could modify again in those operators to work even better. And doing that, we managed to have good results in all the examples, and get to the publication of the article a few months after. Yeah.
Oh, okay. So you're the one that came up with that little trick to address the boundary case for like the product T norms and stuff like that.
Right. And of course, always with feedback from Luciano and Michael Spranger, and of course Arthur Garces. But yeah, so my contribution was this stable operators, also the guarded quantification, which was a trick to avoid having zero gradients in too many parts of your computational graph. It's just like you reduce the complexity of the computational graph by using guarded quantification, and and also a re-implementation of the framework in TensorFlow 2, because at the time it was in TensorFlow 1, and everybody hated TensorFlow 1. Everybody was switching to PyTorch, and so I helped re-implementing it in something that was a bit more usable, TensorFlow 2. Yeah.
Oh, okay. Would there be any plans to port LTN over to PyTorch?
Yeah, actually, there's a few people have made this port, including some student from Luciano. So now we have in the official repository for logic tensor networks, one of the sub directories is for the PyTorch implementation. When we test out new ideas, at least from my side, I work on the TensorFlow version, but the PyTorch implementation is perfectly stable with what was in the and has everything implemented that was in the article back then.
Oh, really cool. Luciano?
Yeah. No. If you want, I can introduce the student.
Okay.
Okay, but that's okay. I think that the Sami's contribution was really fundamental to make it, an idea more practically used, and introduce a lot of important enhancement to make this idea really working. Otherwise, it would have been just an idea and stay there. So I was really thankful to Sami for this.
Yeah, I have a feeling, I think between seeing those results and the differentiable fuzzy operators paper that you mentioned, I think there's going to be a lot of research that is going to be along those lines in how do we do things to tame gradient descent in order to drive better neurosymbolic results. I think that's going to be a big area, and there's going to be a lot of empirical studies, a lot of things like, these lists of operators and how they perform. So along the lines of results, what do you view as maybe some of the more exciting results that you think bodes well for the future of LTN, Luciano?
Well, one of the themes that we are planning to work, and we are starting also to work, is to extend the LTN approach to data that are more structured, like temporal data or graph data, where essentially you have you have an underlying structure of the data that and what you do in one particular point is influences also the other. In particular, the temporal part is really important. And this, of course, allows us to impose a constraint and to reason about temporal logic, temporal evolution, and things like this.
Oh, so would you be looking to support like something like LTL, or would this be something different?
That's one option. There is already some work considering LTL, in particular LTLF, some work of PhD students in Rome, I think. We were more interested in considering more, say, first-order logic approach that consider intervals, Allen relationship between intervals, and things like this.
Oh, okay, really cool. So just to wrap up this first part of the interview, what do you, kind of looking beyond sort of near-term research goals, such as these temporal extensions, what do you see as the future of LTNs in the field of AI? What role do you see them playing?
Well, it's a very difficult question to answer. I cannot predict the future, to be honest. I think that ideas and systems somehow they go from person to person, and they influence the thought or the idea of other people. And my understanding is that so far LTN has done very well this job, in the sense that papers about LTN are not only by us, and after the first publication of LTN, there has been many people who start considering to enhance, to develop different systems on neurosymbolic integration. I think that LTN was one of the first. And so these, so what will happen in the future, I really don't know. I can see the past, and I see that LTN influences quite a lot the literature on neurosymbolic integration. And I hope it will influence more by new ideas. And that's the only thing that I can say.
What are your thoughts on this, Sammy?
Yeah, it's a very good question. So one thing I've noticed in working with LTN in the industry is I really think LTN, and maybe neurosymbolic AI in general, can help connect AI models with experts of a given model, a given domain, sorry. So that's in the context of knowledge-aided learning. So all those concepts of constraints and so on, I think it can sort of bridge AI and experts that already are in the field. And another thing, it's not about learning here, but I think in general it can give some structure to neural networks. So here it's works that do things like complex querying or explainability and so on. I'm hoping to see LTN on other neurosymbolic methods sort of be something on top of all those ChatGPTs and so on to kind of like make them work together. And then I think that to get there, we need some huge AI breakthrough that uses neurosymbolic, so that someday something like AlphaGo, but that uses a neurosymbolic method. And yeah, I'm hoping we get there soon.
No, it's when I gave the Neuro Symbolic tutorial at AAAI this year, several people came up expressing a very similar, notion of Neurosymbolic really needs its ImageNet moment to become real mainstream. Well, thank you both. And to the channel, that concludes part 2 of the interview. Stay tuned for part 3. So welcome back to the channel. I'm Paulo Shakarian, and this is our third and final part of our interview with Luciano Serafini and Sami Badruddin, 2 of the co-authors of Logic Tensor Networks. So in this part of the interview, we'll talk about, sort of the future of AI, kind of some broader ideas, specifically artificial general intelligence. Many people believe that neurosymbolic AI represents something that can really help push our field toward artificial general intelligence. And maybe start with Luciano. What are your ideas on how neurosymbolic AI and neurosymbolic reasoning would contribute toward the goal of AGI?
Again, I think that we go back to the big problem of symbol grounding. Okay, so AGI cannot be done without the symbol grounding problem. As I intended, AGI is the possibility, as far as I know, of building up an agent, a general agent that is capable to to behave intelligently in an unknown environment. So the agent needs to be able to acquire autonomously knowledge about the environment. And as John McCarthy says in the initial paper about artificial intelligence, there is no knowledge without being able to express this knowledge with some symbolic method. So symbol grounding is important, knowledge is important, and communication of knowledge is important. So once you have communication of knowledge, how another agent can use the knowledge and not to learn it directly from scratch. And here is where neurosymbolic integration is important. You have to put together the knowledge that somebody else communicates through symbols to you, and the knowledge that you acquire by looking and experimenting the world. And this is necessary. Otherwise, if all the knowledge comes from data, then every single agent will have to learn its own knowledge, and there will be no exchange of this knowledge via communication. And in particular, for example, if you take the achievement of GPT, of big language models, if you want to build up an agent, a general agent, that use the knowledge, this knowledge that can exploit some general knowledge, this knowledge can come from big language models, okay? So you can use it. And I think that general artificial intelligence cannot be completely separated from, it's tightly connected, let me say, to embodied AI, where the idea that one agent has a body and has an interaction with the real world. And so it has internal symbols, they are connected with the real world. Knowledge is acquired also via acting. And this, I think, is the new thing that we should add also to neurosymbolic integration, which is acting to obtain new experience and to learn more the connection between symbols and perceptions.
Oh, I think that's really interesting. I think there's some people in the cognitive science who talk about the process of um, transduction, which the translation between uh, neural architecture and symbols. Um, and and part of the way that is performed is through action, is through kind of this repeated reinforcement with the outside world. So maybe Sammy, I wonder if you kind of have an opinion on kind of AGI and the role you see neurosymbolic AI playing in the evolution here.
I believe neurosymbolic AI may be one of the easiest way to get to AGI, because so far we have all those like very specialized AI in many different tasks, and neurosymbolic AI may be an easy principle solution for combining those specialized models without retraining something from scratch to get to a general intelligence, a bit similarly to what Luciano says. I believe technically it's possible to build something end-to-end to make a general intelligence with huge data, huge resource, but there's also the question of, other than for the gimmick, is AGI that interesting? Do we need a model that does everything at the same time instead of like many specialized models? And I'm not sure we need it for so many things, so we need an easy way to get there if we want to try to get there.
I think that's, I think the comment about, do we really need AGI, or is everything going to be specialized? I think that's a fair one. On the other hand, I think that Luciano's comment about the interface between agents that could give rise to, AI that could maybe be more modular. Maybe the future of AGI is, maybe along the lines of something more modular. I mean, what are your thoughts on that? Do you feel that as an industry guy, do you feel that kind of the current way AI and machine learning work is good enough for engineering purposes? Or do you think that this modularity, these ideas of symbolic interfaces are going to be required going forward?
Yeah, I definitely think so. That modularity is so the point I was trying to make is that if we don't rely on modularity, then we need to invest a lot of resource to build those general intelligences. And relying on modularity would reduce that by a ton and make it actually worth it to explore. So yeah, I definitely think it's a good idea.
So, so one thing so Henry Kautz introduced this taxonomy in a talk he gave at AAAI several years ago, where he had, different classifications of neurosymbolic systems. And the highest level, he talks about the embedding of a combinatorial reasoning within a neurosymbolic architecture. And he hints a little bit that this is a key, something that he felt would lead to perhaps AGI. In my view, there hasn't been a whole lot of work that's been directed toward this. What are your thoughts on, doing very sophisticated reasoning tasks that may require, combinatorial type algorithms to take care of that within the context of a neural architecture?
I don't know. I mean, I can express a very polarized opinion, but well, I think that combinatorics, I mean, current computers are much better in combinatorics than humans. So if intelligence, my point is on trying to implement combinatorics into a neural symbol in neural networks. I don't understand why. I mean, I don't understand what's the main goal, why one should do this. The only reason that I can see now is just to have approximate results in combinatoric when you have large problems. But we are, as humans, we are not very good in combinatorics. Still, we are intelligent, most of the cases. Okay, so I don't know if I'm a bit kind of confused about this type of argument and research line.
I guess I bring it up because I think of things like, the argumentation process and defeasible logic, abduction queries, deduction in certain logics that are end up being combinatorially expensive, and there's been a lot of work kind of more on the logic side or on the symbolic side on these things, but they haven't, many of them have not been fully integrated into a neurosymbolic approach. And so when Kautz mentions that, I kind of wonder, is that a step that we need to take, or is it or does it look like something different?
Okay, maybe I misunderstand what you mean and what you report, because I was thinking that you do the combinatoric inside the neural network. What I'm thinking is that all the work that has been done in all the field that you mentioned about abduction, but even probabilistic reasoning. Okay, there is a lot of combinatorics.
Yeah, of course.
But that type of reasoning should stay there. And the point is that you have to integrate this reasoning with some neurosymbolic, with some neural network, but not to replace this reasoning with neural network. That was my point.
Oh, yeah. So I think that I probably would agree with, yeah, I mean, to clarify, I meant integrating that into a neurosymbolic architecture. So
okay.
Yeah.
In that case, I agree. At AAA, I was talking with other researchers on the possibility of having a narrow symbolic integration where the logic is non-monotonic. Okay, so the logic part is non-monotonic reasoning, default logic, and things like this.
Mm-hmm.
Is there anything around about this? No, as far as I know. Maybe yes, but I don't know. I'm not aware of anything like this, and it should be interesting to see.
No, I think that would be. I think
There will be. Mm-hmm.
So. I know we're coming up on time, but I'll just end the conversation with one fun question: is what would be your prediction on how far in the future we'd see something that we would be able to call AGI?
Sami, you answer this difficult question.
Hey, it's YouTube. We got to ask questions like this once in a while.
It's like a bit. I think in the next decade we're gonna get to a first modular AI, as we're talking about. That's my intuition.
Luciano?
I think, well, every 10 years something comes out. So yeah, perhaps the next general artificial intelligence will come in 10 years. I agree with Sami. Let's see what's going on. It will be something like ChatGPT, but general intelligence on larger space.
Okay. Well, we'll follow up in 10 years and we'll watch this video together and see if
Let's see.
we're right. So,
Yeah.
well, hey, thank you both. I appreciate you taking the time. And this was a fun conversation. So, thank you very much.
Thank you to
Thank
you,
you.
Paolo.
All
It
right.
was really a pleasure. And thank you for organizing all this channel.
No, my pleasure.